Hello and welcome to Golden Droplets episode number 32. My name is Ricardo Valls. I'm the principal and founder of Valls Consultant. And in today's episode, we're going to continue talking about systematic of the magmatic processes. In the previous episode, we saw several softwares that you can use to process photographical data. And today I will be talking about this book here, which I recommend you, and what you can do and how you can interpret your petrographical data. So, once again, Golden Droplets episode number 32. Enjoy! Hello and good morning. I'm here to talk about some of the books that I publish at Amazon.com. Today I'm talking about my Bible for magmatic rocks, which is called Systematics of the Magmatic Processes, a practical approach to the study of petrological data. This book is one of those books that I think every senior geologist should have on their desk. It's not only a compilation of all the theory and basic knowledge that you need to have to approach the study of magmatic processes and all the rocks related to magmatic processes, and more important, all the deposits related to magmatic processes. This book could be useful for university level. It contains, as I said, basic information on all the magmatic processes, all the rocks, etc. But it contains a description of all the type of assays and experiments that you can do with your rocks. I have found cases where a geologist will take a rock, send it for XRF, get the results, and he just look at the silica content and say, okay, silica is above 60%, this is a granite. And there is so much more that you can do with your geochemical data. And this book explains you how to ask, how to process the data, how to identify rocks in the field. And there is a section, quality assurance and quality control, which, by the way, I have presented in a previous video. But mathematical modeling, basic geomathematical modeling of the data, etc., including concept of compositional data analysis. It includes several cases, real cases from around the world. I work almost in every country in the world, and a very chapter dedicated to how to identify the most probable magmatic processes. So if this is a melting, it is a contamination, and this question not only has a theoretical value, but it also has a very important economic value, because different type of deposits will be related to different type of magmatic processes. The book also includes several appendices, useful descriptions of results. So it's a book that I really recommend for geologists to have it handy on a magmatic environment, like granitoid, volcanic rocks, etc. Not for sedimentary rocks. This is not for sedimentary, this is for magmatic, and not for metamorphic. Thank you very much for your attention. You can find the book at Tom. Thank you very much. Let's take a look inside the book. The first chapter starts by talking about the main characteristic of rocks in general. It has many pictures. It has a chapter about the chemical and mineral composition of the different type of rocks. For example, this is the table of the major oxides according to Clark. Then you have the silica content for different type of igneous rocks, from ultrafelsic to ultramafic. Then we talk about the mineralogical composition. Of course, pyroclast being the most common mineral, followed by quartz and amphibole and pyroxenes. Then we talk about the structure and texture of the igneous rocks with several examples with pictures. This is very useful when working in the field. Then we talk about the textures. And as I mentioned before, there will be an appendix in the book with a flowchart that will allow you to identify all these type of textures in the rocks. But again, every texture will have pictures, so will help you identify those in the lab and in the field. There is a section for the nomenclature of the igneous rocks. You have here, for example, the double triangle by Rekensen and the AQP triangle. There is a section for volcanic classification of rocks. Again, all the rocks comes with pictures, some of them microscopic, some of them macroscopic. So this first part of the book is very useful to give you an idea of what to expect when you're working in the field. Okay, so it has all sort of mineralogical, chemical descriptions, and it's divided for each type of rock, for igneous and effusive. You have plenty of tables that you can use for normalization and to compare your result with these tables. And it also contains a chapter about the ore minerals that are commonly found in these types of rocks. Okay, you have microscopic descriptions. So if you're working with your microscope, you can use this too. So it's a book that you can use in the field and in the lab. But let's look at the next chapters. The next chapter is the field study of igneous rocks. As you can see, it contains several chapters on the main characteristics, the main minerals, and several techniques that you can use to identify rocks. For example, we jump here to staining techniques. It shows you the chemicals that you need, the procedures that you need to do, and how to do it in order to do a stain testing for determining different minerals. There is also a chapter on express geochemistry, which is a series of tests that you can do right in the field to identify the presence of several elements, and that way you can identify the mineral. Then we have the igneous rock identifier, which is a flowchart that will allow you to identify the rock just following a series of questions, very simple questions. For example, let's say you take example, is it a dark rock? You say yes. Next question, is it heavy? As you can see, these are really simple questions that you do, and by the end you will get to the name of the rock. The igneous rock identifier is included in the attachments of this book. As I mentioned before, there is a similar flowchart to identify the textures of every type of rocks. And finally, there is a document called the Rock Dossier, which is an Excel document that contains almost all the information of chapters 1 or 2 of this book. All this documentation will be saved on the Mendeley, so you can access, download it, and use it as you need. Next, there is a section of naming rocks and alteration in the field. This follows the British Geological Survey instruction on how to identify the names of the rock, and also combined with the usual Canadian way that we describe rock. We start by describing the alteration, meaning the hydrothermal alteration, then the name and the qualifier of the name, the texture, and the mineralization. And there is this section about how to do these classifications and finding the names and all the approved names, all the root names. There is a section for laterites specifically. These are the different qualifiers that you can use. This is an example of a flowchart for the identification of approved and root names for sedimentary rocks. So you can see here, it's very simple. Is the sample react to ACL? Yes. Are the grains more than 2 millimeters? Yes. Then it's a calcirrhodite. If no, if the grains are above 0.06 millimeters, yes, then it's a calcarenite. If not, it's a calcilutite. So you see, these are very simple questions, yes, no, and you will get to the root name of the different rocks. Okay, there is a similar classification for consolidated volcanic and unconsolidated volcanic clastic rocks. You have the same for granitic rocks. And as I mentioned, there is a special part for ultramafic rocks and lateritic environment. This is an example of how you get the texture of metamorphic rocks. Again, it's very, very detailed, and it will be very important for you, very useful for you in the field. Then we have the systematic of the magmatic processes, which is a section is a little bit more theoretical. However, there are a lot of practical applications too. So in this section, we are looking at partial melting, fractional crystallization, mixing, and contamination. And it is very important to define this process in the field because each of them will have implication on the type of ore that you can find. So you have description of what is a partial crystallization. This is a general graphic of how these things work. So you get from solid mafic composition to felsic composition and how the system works from partial melting to fractional crystallization, with the increment of temperature or the decrement of temperature, how you get to this extreme results around the graphic. For partial melting, we will test the equilibrium of batch partial melting, the disequilibrium partial melting, the fractional melting. You will see here there is very detailed explanation of all these steps and what are the characteristics when you get, for example, I don't know, a partial melting, what would be the characteristic of the mineralogy that you will see. So all these models are included in this book. Also, I will put in Mendeley software that will allow you to process your data to determine the most probable magmatic event for your samples. So you have mixing, you have contamination, etc. So there is a section in the book for the quality requirements and the pre-elaboration of your data. These include, of course, the use of quality controls, the pre-elaboration of the data, minimum thing that you need to do. For example, testing the quality of the analysis. Specifically here, I'm talking about the duplicates, okay, and the techniques to determine if the data from the two samples, the original and the duplicates, are correct. The detection and elaboration of statistical outliers or hurricane samples, determination of the distribution law, the security intervals, how to determine the most informative elements, and other interesting things for preparing your data. There is a section here with examples, to test the quality of the data, to determine hurricane value, to the informative element, and the solutions are down here. Very important step in magmatic studies is the determination of the degree of incompatibility. And there is a section here dedicated to this and how to do it, how to work with it. It's step-by-step process, and how to interpret the spider diagrams, etc. And the most practical part of the book is the determination of the most probable magmatic event. As I said before, I will put on Mendeley all the software that you're going to need to do this study. So this is a partial flow chart of the different magmatic processes that are covered here. So we have for melting, we have fractional and batch. For crystallization, we have in situ and simultaneous escape, and mixing and contamination, we have a series of them. Remember, the importance of this thing is that knowing the type of crystallization, you will have a better idea of the type of ore deposit that you may have in your rock. There is an example of an evaluation of the heterogeneity of the suite of samples that you can test, and the different graphics that shows you how to interpret these results. Again, the book contains a series of exercises to help you first learn better these techniques and to process your own data. And again, all this software will be in Mendeley. So we have here, for example, how to determine the composition of a rock based on the chemical analysis, the bulk partition coefficient, the relative incompatibility of elements, what is the most probable magmatic event, and again, as always, there is a chapter with the solutions, so you will know all these things. The same thing for fractional crystallization, for mixing and contamination. And the book ends with a full sequence of what you do to interpret your data. There is a section in the book dedicated to compositional data analysis, which, as I mentioned before, is the most important statistical tool that you will have, especially if you work with correlations. We also talk about factor analysis and many other mathematical tools that you can use to study your data. Then we have the series of appendices, as I mentioned, the IUGS classification, the Gabor classification, ultramafic. This is, for example, the igneous rock identifier. This is the igneous rock texture identifier. And I also included some appendices like the student test that you will need to compare the similarity between duplicates, and a table with the mineral melt distribution coefficient. You will need this data to process your own data in order to determine the most probable magmatic event. This is a general view of the book. It has much more information. It's a book that I hope you work in a granitic environment. This is a book that needs to be on your desk. It will help you in the field. It will help you in the lab. It will get you in front of your computer. And with this, we finish our Golden Droplets episodes. And as always, wish everybody good health and wealth. Until next time, have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe. And don't forget to click the notification bell.